Hong Kong, 1990s. Palm and other PDA manufacturers were looking for a chip to power their devices that was both powerful for the time and had good power consumption. Apple tried it in 1993 with the Newton but failed because the device required separate integrated circuits for everything, meaning extra cost for the device and extra power consumption. So, full-scale Motorola Dragon Ball was designed by Hong Kong doctors Dr. HKU, Dr. Ray C.C. Chong, and Monica Leong that focused on the idea of a single chip integrating multiple components inside of it, the same philosophy as modern-day smartphones. The name of the chip is related to the famous Japanese anime, since one of the designers used to love it when he was younger. The project was based on Motorola 68k core but with some enhancements to be an all-in-one low-power system for handheld computer use. These devices were PDAs that ran Palm OS, running on hardware manufactured by Palm Inc. and other companies. The first CPU, called Motorola MC68328, launched in 1995 and was based on the Motorola 68k processor. Like the 68k, it was a 32-bit processor with 32-bit internal and external address, 24-bit for the future EZ and VZ versions, and 32-bit external data bus. Since it was running on a mobile platform, it added color and grayscale display controllers, infrared transmitters, PC speaker sound, serial port with UART, and ILDA support, UART bootstrap, real-time clock, and it was able to directly access DRAM, flash ROM, mask ROM, and has built-in support for touchscreen. The second version, EZ-MC68EZ328, launched in 1998, had a lower cost with improved manufacturing. Like the first version, it ran 16.58 MHz and ran up to 2.5 million instructions per second. The third version, VZ-MC68VZ328, launched in 1999, called Dragon Ball GT, was focused on higher efficiency and power. The clock speed was 33 MHz with 5.4 million instructions per second. The fourth and last version, SZ-MC68SZ328, launched in 2002. Dragon Ball SZ had a frequency of 66 MHz and its computing power reached 10.0 million instructions per second. It added noticeable features to the SoC like analog to digital converters, touch panel control, DMA controller, serial I2C interface embedded SRAM, MMC as the host controller, and USB controller as storage media. But soon after, the industry understood that ARM, another RISC architecture, was the best for the future of mobile handheld. But full-scale Motorola Dragon Ball still has been a success, powering up to 80% of the worldwide handheld market between 1995 and 2002. Sony manufactured its latest version of the Clear by adding custom chips to increase its capabilities, like adding a high-resolution color screen, but soon after they switched to ARM as well, like most manufacturers. Palm Inc. only supported ARM since version 5, and also Motorola started manufacturing its upcoming chips based on their own ARM technology, the MS-1, that was faster than the Dragon Ball chip.